We're Group M7 and we're going to talk about the state of the art of 3D printing and our projections for the next 5 to 10 years. Additive manufacturing technologies have reshaped the world of production. 3D printing processes have saved organizations millions of dollars, and the applications and potential of these devices continue to grow. It's common to find these technologies in research and development labs in fields such as aerospace, biomedical, robotics, and more. Since ideas of 3D printing first emerged in 1977, significant progresses have been made in developing and advancing the field. Only 3 years after the first functional 3D printer was created in 1986, TV shows such as Good Morning America began introducing these devices to the public. The product quickly caught on. In 1993, 3D printers were being used to produce shell molds for casting operations. 6 years later, Aeromat introduced the first 3D printer which could print metal. In the 2000s, 3D printed organs were introduced and small at-home printers emerged. By 2007, material research in the field had advanced to a point where materials could be used in 3D printing to mock certain desirable material properties, such as hardness and ductility. Beyond 2010, new applications of 3D printing began to arise, such as printing of cars, aircrafts, and candy. In 2013, NASA embraced the technology for the first time. This all led to the current state of the art of 3D printing. Today, there are quite a few materials which can be used for 3D printing, such as nylon, stainless steel, and ceramic. The price is significantly lower now than it was when the technology was first introduced, and for this reason, 3D printing is more accessible and is becoming more common. Extremely complex parts are now being created and used for applications in large-scale production, consumer goods, and the biomedical industry.
The current state. Currently, the 3D printing market is dominated by 3D printers for manufacturers and businesses, such as the HP Jet Fusion 3D 3200 in the bottom left. And there's not too much popularity at the moment in 3D printers for the home outside of just hobbyists. Current home 3D printers are very basic and they're relatively low quality, like the Lulzbot mini desktop 3D printer down there. Just by the name, you can tell that it's not going to be a very technologically advanced 3D printer. In the future, we're going to see more uses of 3D printing in education as technologies like the 3Doodler in the bottom left are paving the way for use of full-fledged 3D printers in education. And also on the bottom right, the Robo 3D printer kit for a quadcopter. Essentially, you print off each of the individual parts and then put it together. And that could also be something more home friendly. And we're going to start to see more of things like that being advertised in the future. And another area is part replacement, because eventually common parts like screws that might go missing or something like that, eventually you could have specifications for those which you could use to 3D print your own screw. Let's say you lost a screw on your laptop. Also, advances in technology that will allow for more advanced, cheaper home 3D printers. That's inevitable. As the technology increases, the prices for these home 3D printers are going to go down, and they're going to be able to have a lot more capabilities, as well as further innovations in the streamlining of 3D printing to allow use for the everyday person. So obviously, the everyday person wouldn't be expected to have extensive knowledge in CAD software, so they might have the simpler interface, and maybe you could make something similar to that picture below with a 3D printed phone case.
It is safe to say that not a single vehicle of any kind is made today without additive fabrications. Top companies are eager to make the first move to see this technology. As of 2016, a number of top producers like Rolls-Royce have 1,000 plus 3D printed parts in the production of a single vehicle. Mercedes has also acquired a 3D printing spare parts factory. Some of the advantages of 3D printing over traditional manufacturing is the lower number of production steps. You don't have to go through many steps like prototyping, manufacturing, assembling, or shipping. All you have to do is make your design and 3D print it, and you have your end product. Of course, this will lower production cost by reducing shipping and storage costs, potential limitation of import costs through localized productions. And also one more advantage is the efficient use of materials. Expensive materials like titanium scraps that would otherwise be a waste and unusable with traditional manufacturing methods can be reused in 3D printing and could save companies millions of dollars. As we can see, 3D printing will continue to expand in many areas. In the future, 3D printing is moving in several directions at this time and will continue to expand. Up next are 3 concepts of how 3D printing could be implemented in production. On-demand manufacturing, which means goods are produced when or as they are required, based on real-time and current data from clients. For example, a car repair shop wants a specific part for a specific car, for a specific model, to fix a car. All they have to do is inform the spare parts services, and they will get it printed and delivered to them. 3D printing shops. This concept is easily self-explanatory. The supply chain factories will become smaller and more spread out through different locations, replacing gas stations, stores, and supermarkets by retail mini factories with 3D printing infrastructures. 3D printing food. Imagine it's Friday night and you want a pizza, but instead of calling your local pizza for delivery, you just print out your dinner. Or use 3D printing to customize nutrients in all of your meals and have control over all of your ingredients.
3D printing was first used in the medical industry in the early 2000s. At this time, it was most dominantly used for the production of dental implants and prosthetic limbs. The digital imaging data produced by MRI, CT, or X-ray processes can be readily converted to an STL file for printing. As a result, very complex geometric shapes with high accuracy can be produced. In addition to the desirable physical traits of 3D printing, time and cost are reduced since a device can be designed and printed in as little as a few hours. A major use of 3D printing today is in the manufacturing of invisible dental aligners. These highly customized devices can be made very quickly and economically using 3D printing. Invisible aligners provide superior aesthetic characteristics and very predictable tooth movement, which make them so popular. These printing technologies are often used in the internal implant production because of their quick production rates and high accuracy. Titanium powder is a common material used, but other materials such as polymers are also used for some components. In the future, advancements in 3D printing will likely allow new procedures in the medical industry. Samples of skin tissue have been produced and would be valuable when treating burn victims. When this process becomes viable, it will likely be performed directly on the patient's body. Functional kidney, liver, and cardiac tissues have also been produced. There are obstacles to overcome before whole organs can be printed, such as the presence of multiple types of tissue, like vascular, neural, and muscle tissue. When this technology becomes a reality, patients will receive organs promptly and at a lower risk of organ resistance. These processes can also be used to produce organs for pharmaceutical research rather than relying on animal testing.
Since the first 3D printer was unveiled in 1986, there have clearly been significant improvements in the field. Here's a picture of the first 3D printer and the first 3D printed object, and here are some of the objects being printed today. Researchers and developers are anxiously working to progress additive manufacturing and explore some of the potential future applications. The field is still in its early days, and there is a lot of promise for the future of additive manufacturing.